Good evening, class. How are we doing today? All right. Can you hear me all right?
Good.
All right. Thank you. Thank you. Well, a couple of things before we get started today, okay? Number one, your problem set number one is due today, so you need to upload to D2L, okay? So every Tuesday, 5 o'clock is your due date, okay? And then the next thing is your post-test. Your post-test is will take place tomorrow. So you will find your convenience time to do the test. For instance, if you are available like at 9 o'clock, you can just go D2L and do it and then upload to D2L, okay? And do you have any questions for your post-test?
The post-test, is it like the pre-test where we just do it with the scratch paper and then just upload it?
Yes.
The same way?
Yes, correct. Just like your problem set number one, okay? And same as your pre-test. I just changed the number, okay? And then you will take the test tomorrow, okay? Tomorrow, whole day, you can find your convenience time and then just do the test, okay? And then upload to detail just like you do the homework, okay? And after this class, you still have any questions for the problem, you can stay here and ask me, okay?
So with all tests, will you just upload all tests and then we have to just submit pictures and show our work, or will some of them be like lockdown browser?
Yeah, pretty much just like you did your home problem set number one, okay? Your problem set number one is just kind of practice test. And I already see many people, already upload, so you should be no problem to upload. So you would, once you upload, you go to assignment. And then we already create a post-test column for you to upload, okay? So tomorrow I will announce the problem and then you will go ahead and do the test. And you upload just like you problem set number one. I think so on the very bottom, on the column for the assignment, you go to assignment to upload, okay? That will make it you easier. Because you already know how to do upload problem set number one. So you should be no problem for that, okay? Okay, if no questions, then let's go ahead. Today our plan is we gonna go over lesson one and finish lesson one. We take a like a 5-minute break, and we can continue lesson two. Okay. All right, let's go ahead to the lesson one. Lesson one is addition of whole numbers. So you will see A plus B. A is and B are called addends. So here we have name. This is called addends. Okay. And then whole number addition properties. We have several properties. We have a closure property. We have a commutative property of addition of whole numbers. And we also have associative property of addition of whole numbers. And the last one is identity property of addition of whole numbers. Now, what is the closure properties? Let's say because we have A and B right here, right? So A, let's say A is equal 5. B is equal 3. So we take A plus B equal 8. So that's the 5 plus 3 equal 8. And look here, closure probability are any two whole number, and then they can create another unique number. Oh, 8 is a unique number. It's not 5, it's not 3, it's a unique number 8. Okay, this is called a closure property. Okay, and the next one is called commutative properties. So let's say A equal 5, B equal 3. So you take because this property is say A plus B equal B plus A. So when we teach elementary school, we give a student example like 5 plus 3, then 3 plus 5. We're not direct again give them the no, we're not just give them the formula, okay? We have them to come with the general rule, okay? So 5 plus 3 is A. 3 plus 5 is A. Then therefore this is equal. Then this will be equal. Is that right? If from here you can say this is equal, this is equal. So therefore A plus B equal B plus A. But you want to give a student a whole bunch of examples, like you want to have 2 plus 3, then 3 plus 2, and then we might discuss and come with a conclusion of this instead of give them the property, right away. I mean, in the lesson plan, we need to give the student different examples. Let's say, okay, we're gonna do the example. This is example 5 plus 3, 3 plus 5, 2 plus 3, 3 plus 2, 1 plus 2, 2 plus 1. See if they are equal. If they are equal, yes, they are equal, and we prove this is equal. This is 3 plus 3 equals 3. This is 5 equal 5. This 8 equal 8. Then we can make a conclusion. A plus B is equal B plus A. Instead of you just give in the formula, okay? Does that make sense to you in terms of your lesson plan?
Yes.
Yes.
Don't have a student to explore instead of the traditional approach is you just give a formula, oh, just plug in. No. I think the lesson plan, the better lesson plan, have a student to think about and find all kinds of examples and they come with a conclusion together, okay? Then we can say commutative property. Does that make sense? Similar for associate property.
Yes.
Similar associate property. I will not give the student here this one right away. No, I'll have them to explore, okay? Now here example. Let's say A equals 3, B equal 2, C equal 1, okay? So now I want to take 3 plus 2 plus 1. I will not put on equal sign right away, okay? Because I want to have a student to think about it. And before they say yes, then we can do it, okay? Okay, 3 plus 1, 3 plus 2, how many? It's 5, right? 5 plus 1, how many? It's 6, is that right? The next one, 2 plus 1 is 3. 3 plus 3 is 3 plus 3, which is equal 6. All right, now 6 is equal 6, makes sense to you. Then 5 plus 1 equals 3 plus 3, makes sense to you. then we can come with this 3 plus 1 bracket plus 1 equal 3 plus 2 plus 1 bracket, all right, or parenthesis, all right. So then we can come with a conclusion. Oh, A plus B, put a parenthesis there, and plus C equal A plus B plus C. So we can make a conclusion for this and give a whole bunch of examples, like maybe at least the 3 examples, for student to explore, and then we can come with a conclusion together. And that would be a good lesson instead of just plug in, okay? The next one is called the identity property of addition. There is a unique whole number. Okay, whole 0 is a unique whole number. And then additive identity such as any whole number. If we have A plus 0 equal A is equal 0 plus A. So 0 is a very unique number. You plus anything and you become the number itself. So for instance, if I have a 3 plus 0, and which is equal 3, and which is equal 0 plus 3, right? 0, okay. So this is called the identity property, okay? All right, finish up our addition properties, and then we need to learn some methods, okay? Methods. So we have some methods I want to go over with you. Okay. The first one is draw pictures, okay? Draw pictures. And then I think the methods here I will go over with you is from easy to difficult, okay? From, let's say, slow learner to quicker learner, all right? So in the classroom, we have diverse learners. So I think so from we have many different ways, and we can help many different students, diverse students, okay? Draw pictures, okay? For instance, 5 plus 2 equal how many? So I would say 5, okay? So 5 apples. I think so you can draw apple better than me, right? And then plus 2. And then how many in total? So we count 1, 2, 3, 4, 5, 6, 7. So therefore, the answer is 7. Okay. So I think you can draw pictures like apples or flower or anything, that for student. So that is the first way we can do. And then basically this is from actually object. People can touch, can feel, like you have apples. But this is also this is a more like is more concrete. Then how about another one? See, 5 actually for student is another different level. It's kind of more symbolic. It's not a concrete, but apples is concrete. So that is, I would say, this is most easy one. Okay, and next one, we move on to next level. Okay, called make tick marks and count by 5. Okay, so make tick marks. So kind of like a transition from the concrete, okay, to symbolic. Okay, so 5 we can say 1, 2, 3, 4, 5. I think so many of you, when you are elementary school, you learn this, right? So you plus 2, 1, and 2. So how many in total? The total is 7. Okay, so and count by 5. So 1, 2, 3, 4, 5. Every 5 you make a tick marks. Okay. Now, this is a US classroom. This is a US classroom. We use make tick marks. Okay. But what about you have a new immigrant student coming from Asian countries that do not use the tick marks, but they have a similar one, tick marks, right? They use this one. They use it the character like this represent 5. So therefore, when I do it again, so 1, 2, 3, 4, 5. Asian country from Japan, China, Korean, Taiwan, and some place, they use the tick marks like this, right? Interesting, right? Yeah. And then it's very similar to our tick marks. And how about 2? So 2 is 1 and 2. So therefore, if they will count, this is 7, right? So then there's another different culture. You can see, you can see they are using similar way, but using different representation, right? But if you know any like different something related to tick marks from other country, let me know. I like to know if you know someone from different country and they use tick marks like in different way. Let me know. Okay. All right. Next one is count up and use the number line to count up. Okay. So 5 plus 2, you draw the number line like this, and you would draw the number line. Okay. Now number line, I think so. When I introduced the number line, when I remember when my daughter, she is around first grader, and then she learned something like this, and she had no idea what the number line is. She always thinking about this way is the greatest number. All right. You can try. You can try if you have a children at home. You're gonna try. See if they understand. But actually, I'll define from here to this way, from left to right. Left to right is the greatest number, right? Yeah. But I remember when my daughter, she was first learn the first number line. I was testing if she know the concept. She does not have no idea. She thinking about right to left is the greatest number. So I think the number line has to be introduced to. I think it's good for a second grader, and then can see the visually. So 5, what's the 5 mean? 5 means I'm gonna draw in a car, and starting from here, starting from 0, right? Then 8. 8, what's the 8 mean? So you get it. You want to get a meaning for this, okay? Instead of just do it. Who knows how to do it? Because younger children, they don't know how to do it. So that's why everything you need to label it. You cannot assume student every first grader and second grader they know this. No, I don't believe so. Unless they are genius. People has to kind of learn and then get a definition. They will know this. Yeah, does that make sense? So 5, I would say, okay, I'm driving a car. Again, tell a story. I'm going to tell you a story. And then I was driving the car, starting 5. Okay. Starting 5. And 8, what is what? 8, that means addition. That means moving forward. Okay. And then 2, moving another 2 units. Right? Moving forward another 2 units. Okay. So I'm starting 5. So start, everything start from 0, starting 5, that's the 1, that's 2, that's a 3, that's 4 and 5. Okay. That means a 5. Right? Now, what about addition mean? Addition means continue moving forward, right? Forward for how many units? For another 2 units. So we're gonna for another 2 units. So where is the location of the car? There's a 7. Let's say I start with a 5 mile, and then I want to drive 2 more miles. How many in total? So I drop already 7 miles. Does that make sense to you for this example? And you need to give a definition for this. What's the meaning for addition? What's the meaning for this? All right. What's the meaning for 5? 5 means I'm starting 5. And then plus, that means moving forward. 2, that means 2 more units. Moving forward 2 units. All right. To the left or to the right? To the right, because the right means number is getting bigger. Does that make sense to you? For number line?
Yes.
Okay. All right, next one is decompose, compose, or regroup, okay? I think so we already kind of talked about this last week about decomposition, decompose and compose in our review last time. Remember that? So compose and decompose. 8 plus 9. Okay. Now 8 plus 9, we want to decompose 8 plus 9. Now, how should we do 8 plus 9? We decompose. So I want to decompose. I want to decompose 7 and 1. Because I know this is a 9. If I add 1, I make a 10. Is that right? So therefore, I decompose A is a 7 and 1. So therefore, this make it as a 10. So the answer is 17. Okay. Can I do another different kind of a decompose? Yes. All right. Can I do different way of decompose this? Yes. I can decompose 2 and 7. Can I decompose 9 as a 2 and 7? Yes or no? Another way. And I make this as a 10. So 10 plus 7, which is 17. Another way of decompose. All right. Does that make sense to you?
Yes.
All right. So I want to give you an example. You want to do it, okay? Decompose. Kind of practice with this. Oh, just right here. Well, 7 plus 8. Okay, 7 plus 8. Go ahead, do it. All right. When you decompose, can you decompose 7 as a 5 and 2? Did you get this? So therefore, you got this is a 8 plus 2 is a 10. And once you decompose, yes, 8 plus 2 is 10 and 5. So therefore is a 15, right? That's one way you can decompose. What about the other way you can decompose? Can you decompose A as a 3 and 5, yes or no? Yeah.
Yes.
So therefore, you have 10 plus 5, so you still got 15. Is that right? Yeah. So that's sometimes make children do the addition easier because they can see and they can do mental computation. In the other way, we're kind of training their mental computation, okay? And another way, kind of helping them computational fluency, okay? How about another method called difference from 10, okay? Difference from 10. Now, difference from 10, 8 plus 9. So difference from 10, 8. So we need how many more? We need 2 more. Is that right? To make it as a 10. And then 9, we need 1 more to make it as the 10, right? So difference from 10, we take a 10 minus 2 difference, and we got 8. And here, difference from 10, 10 minus 1, we got 9, right? So we add together. So therefore, we have 10 and 10 and minus 3, which is 17. This is another way of thinking, doing the addition. Does that make sense to you for difference from 10? And let's do another example. 7 plus A. Difference from 10, which is negative 3, minus 3. Difference from 10, we not enough for 2, right? So 10 minus 3, 10, different from 10 is 2, minus 2. So add together, so therefore we still can get the 15. Another way of thinking of doing difference from 10, right? How about, I'm gonna give you example, okay? 7 plus 6, can you do it? Take a minute, do it. Difference from 10. All right, I think that you're done, right? So difference from 10 is negative 3. Difference from 10 is negative 4. So 10 minus 3 equals 7. 10 minus 4. And then put a big addition there. So therefore, we have how many? So we have 13.
13.
Mm-hmm. But that's another way of thinking, you can do the mental computation, Okay. Lattice method. How many of you know lattice method before? How many of you? Are you familiar with the lattice method?
I've heard it, but I've never learned it.
Okay. Yeah, lattice method is another good way, helping children understand the addition. Okay. So let's do 23 plus 87. So you write it down 23 and 87 like this. And you want to do this, okay? And you want to see this, okay? You want to create a grid like this. Okay, are you ready? Three plus seven, how many? 3 plus 7, how many?
10.
10. So put a 10, that means put a 1 there, put a 0 there. 2 plus 8, how many?
10.
10. So put a 1 there, 0 there, okay? And then here is ones. Here is tens. Here is hundreds, okay? So we want 8 together. So 0, bringing down 0 here. 1 plus, so we'll have like a 1 plus 0. So that therefore is 1. So we put it down 1 there is 1. So the answer is 110. I like this way because a student, sometimes a student struggle with, the traditional way student will put on there or put on there, or maybe forgot how to put on the number to carry, right? But this way is much easier for student, okay? Can you try another one? Take a 29 or 78. Can you try this one? And you want to add diagonal, okay? You add diagonal would be tens value. 10 you based on the place value. And here is the ones, here's a tens, here's a hundreds. Okay. Okay, take a minute, do it, see if you can do it. All right, are we done? Nine plus eight, how many? 17, right?
Yep.
So I'm gonna put a 1 there, 7 there. Now next, 2 plus 7, how many?
9.
9
9.
plus 1.
So I put a 0 and 9 there, right?
Oh,
So bring down 7 right here. Add a diagonal here. Not 1 plus 9, which is 10, right? So put on a 0 there. And carry 1. You have carry 1. Carry 1, that means 0 plus 1, which is 107. Does that make sense to you for this problem? Yes or no?
Yes.
yes.
Can we do another one? Okay, do another problem. 45 plus 23. All right. 3 plus 5, how many? 8. So put on 8, 0, 8. 4 plus 2, how many? 6. 6, that means 0 and 6. So we're gonna put down 8 right here. Add a diagonal, 0 plus 6, 68. And how about 0? 0 bring down here, so 0. 0, 60, 0, place value is, see, this one, it give you a clearly place value. This is a hundreds, this is a tens, 100, tens, and ones. Okay. Now I'm gonna do 3-digit number, okay? Since you already know the 2-digit number, can we do 3-digit number? Let's do 3-digit number. I want you to try it, okay? The value for this method is children will be succeed for larger number compared to the traditional method. The larger number they doing this method, they will get more confident. They always get a correct answer compared to the traditional one. Okay, I want you to give you a minute. Try this one. All right, are we down? Okay, let's go ahead, check your answer right here. 7 plus 4, 11. 9 plus 3 or 3 plus 9, how many? It's a 12. 3 plus 2, how many? 0 and 5. Did you get this? Yes or no?
Yes.
Yes.
Then you want to do 1, putting it down 1, and you want to add together 1 plus 2, got 3. Add a diagonal, so 1 plus 2, that's 3. 1 plus 5, got 6. And then 0, actually here. So answer 631. Did you get right for this one?
Yep. Yes.
See, the more digit, you get the answer. I like the latest method because compared to the traditional way, I think that this is better because place value is clear. Okay. Next one, left to right. Left to right. Oh, let's do right to left first. Okay. Okay, this is a traditional US classroom algorithm. And then we will say this is from right to left. So from right to left. Now, right to left, you take a 5 plus 7, how many? 12, right?
12.
Yes, a 12. So put on the 2 there. So you carry 1. 1 sometimes, I will encourage you, you can put on there. You can put on there. Right? So I think that I would like to have a student put on there because there, It doesn't matter if you want to have a student put on there. Sometimes they are missing this, So it doesn't matter you want to put on there or there, okay? But at least you carry one, okay? So put on, I would say there. So therefore, 4 plus 9 is a 13. 13 plus 1, and then we have a 14.
42.
Additional method. Is that right? Okay. How about, can we do left to right? Now left to right is like this. See, we can do the addition from here to there. We also can do the addition from there to there. I will tell you, sometimes you can see on the TV show, people, or maybe people doing the calculation very quickly for the addition. Actually, they are not using the traditional way. They are using this way. Okay, and let me show you how. Okay, and this is also good for quicker learner. Quicker learner can do this. Okay, so left to right, 4 plus 9, how many?
13.
13. So they will put down 13 there, right? So I actually I'm starting here and calculate from here. Okay, left to right, right? And then what's next? 5 plus 7, how many? It's a 12, right? It's a 12, right?
Right.
Yeah.
So answer is 142. Does that make sense to you? Or you can say, 4 plus 9 is 13, 5 plus 7 is 12. I put out the 2 there, cancel this out, it's 442. I think that this one is much quicker, right? Can we do another exercise of this method? Well, left to right. So we are learning smarter way, okay? You guys are college students. I think that you deserve a better way. Can you do left to right? I want to give you a minute and try it, okay?
Yes.
Does it work for you?
Yes.
So left to right, I'm gonna starting from here. 2 plus 8 is a 10. 3 plus 7 is a 10. So the answer is 110. Or you can say, you can do this one. 2 plus 8 is a 10. 3 plus 7 is a 10. Put on 0, cancel this one, put on 1. So 110. Either way. But you're starting from left to right. Now, can we do 3-digit number? Two 48, 957. I'll do left to right. 9 plus 2, 11. Can I put on 11? Yes or no? Then next, 4 plus 5, 9. 8 plus 7, how many? 15, right? So I put on 15 there. So either way you can do, you can put on the 15 there. So you can 5, and then 9 plus 1 is 0, carry 1 there, so that'll be 2 and 1. So answer is 1205. Or we can do this way too. Are we still doing left to right? 9 plus 2, 11. 4 plus 5 is a 9. And then 9 plus 7 plus 8 is 15. Put on the 15, close this out because you carry 1, put on the 0, and then carry another 1 because 9 plus 1 is another 1. So put on the 2. So 1205. You can do this way or you can do this way. You know, if you are familiar with this method, you can do quicker like this way. Okay. But if you start in learning beginner, you can do this way. Okay. But actually is a way of doing left to right. How about we want to do this one? 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Can we do right, left to right? So 6, 6, 6 again, 6 again, and 6. Still working, right? If you do a lot of digit, you still can do it, okay? Do you have any questions so far for left to right?
Nope.
Okay. Looks you are doing good for this one. How about combine left to right and right? Oh, this one combine left to right, right to left. This is for the quick learner, okay? As I mentioned, this is from easy to difficult, right? Combine left to right, right to left. Okay. So I want to combine left to right, right to left. Okay. That means I want to use a both method. Okay. And let's say we're gonna starting calculation from here. I'm starting the calculation. We can add from the middle. We can add from the left to right. We also can right to left, and we also can add from the middle. So if we starting from the middle, how should we do? Can we do right to left first? So if I do right to left, and then I have 7 plus 8 is a 15. Carry 1. Yeah. 6 plus 4 plus 1 is 11. So I'll put on 11 there. Okay. 115 for this. And next, left to right, because we already did this. And how about, so we have left to right right here is a 10. 7 plus 3 is a 10. 4 plus 5 is a 9. Combined together That means 5 there is 1, and then 10. 9 plus 1 is 10. Carry 1 there, so 1. So the answer is 11,015. Does that make sense to you? So I want you to do it. Practice this number. Do it again. See if you can do it. Right to left, left to right. Give you a minute. Try it, okay? All right. 7 plus right to left, which is 7 plus A, which is 15. And then carry 1 there. So 6 plus 4 plus 1, 11. So 1, 15. So right to left. Okay. Now next, we want to do this way. Left to right. Left to right, left to right. So we have 3 plus 7 is a 10. 4 plus 5 is a 9. So add together, that's a 5, that's a 1. Carry 1 more there, so 1, 11. So 11015. Did you got right for this one? Yes or no?
Yes.
All right, very good.
Can we do another one of those?
Yeah, but I want to stick on another problem, okay? The same problem here. Make sure you're okay, then we can move on to the next one, okay? How about if I like to it from here instead of here, okay? So I wanna start from here, okay? Well, someone said they cannot see anything.
I had to rejoin for it to re-pop up.
I did too.
Yes. Okay. But if you're using like a SIU account, you should be able to see, right? Share the screen. Okay. Are we ready? If I like to start with from here, right to left. So I want to do right to left, 7 plus 8, 15. Then carry 1 there. 6 plus 4, 10. 10 plus 1, 11. 11 put on there. So 11, put on 11 there. So 4 plus 5, 5 plus 4 is 9. So put on 9 plus 9 plus 1 is a 10. Okay. So we already did this number. What about the other number we didn't do, which is 3 and 7? So 3 and 7 is put together is a right and left to right. So be 10. Add together 1, 1, 0, 1, 5. Okay. Can we do another problem? Can we do another problem to practice?
Yeah.
Okay, so I'm gonna erase this, and then you want to give you to do another problem. And this method, get this method is for quick learner, okay, not for everybody. For student is smarter, or student is like a college student, yes, we can do that. Or maybe the student is a gifted student, I mean the quick learner, we can do this method. All right, so this time I'm gonna start from the middle right here. And you wanna show me left to right, or left, or right to left, left to right. Okay, are we done?
Yes.
Okay. Right to left. 7 plus 8. 15. Put a 5. Remember 1. And 6 plus 5, which is 11. 11 plus 1, 12. Are you with me for this? Yes or no?
Yes.
Yes.
Now we finish right to left, right? Because we need to do the combination, right? And then we add in from the middle. That's why we add in from the middle. That's why we have a combination for right to left, left to right, right? Now what's next? We're gonna do left to right. Left to right, 9 plus 8. 9 plus 8, how many? 17. Are you
17.
with me? Then 5 plus 5, how many? It's a 10, right? So put on the 0, cross this out. Make it as an 8. And then the rest of it, 6 and 8, 5 and 7, we already done, right? So add together, what is the answer? 1, 8, 1, 2, 5. Does that make sense to you?
Yes.
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 Okay. How about, I'm gonna change the problem, same problem here, but only the difference is, I wanna change the arrow sign, okay? Middle. Earlier we do this, right? So we wanna change to here, okay? Arrow from the middle. Can you take a minute, try it? Right to left, and left to right. All right, let's check your answer on the board because this is right to left. I'm gonna start from 7 plus 8, which is 15. Carry 1 there. 6 plus 5, 11. 11 plus 1, that's 2. Put on the 2 and carry another 1 there. 5 plus 5 is a 10. 10 plus 1 is 11. Does it make sense to you right now? Yes or no? From right to left? Yes or no?
Yes.
Yes.
Next, left to right. Oh, we only have one number need to add, two number need to add together, which is 8 plus 9, which is 17. So add together because combination for those is 1, 8, 1, 2, 5. Does it make sense to you?
Yes.
So we can do
Yes.
either from left to right. We can do the addition left to right to left, left to right, and we also say the combination and add in the middle. Right. Okay, I think I want to take a 5-minute break. Okay, 5-minute break. Come back, and we will go over lesson 2. Okay.
Thank you.
Mhm. Lesson 2. All right, we are going to move to next lesson, lesson 2. Lesson 2, subtraction of whole number. All right, can you hear me okay?
Yes.
Yes.
All right,
Yes.
subtraction of whole number. We already did the addition, and next we'll do the subtraction, okay? A minus B equals C. Now we have a name. We have a name for A. What's the A? A is called a minuend. B called a subtrahend. And then C is what actually is the difference of A and B. Okay, so we have the name for each. That's A, that's B, and that's a C. Okay. Now we have a subtraction whole number. We have a different model. We have a takeaway model. We have a missing area model, and we have a comparison model, and we have a number line model. Okay. Now here is a takeaway model. The real world example. John has $8 and spends $5 for a ticket to the movies. How much money does John have left? So we have $8 in the pocket. Now take away. Subtraction here means a take away. Take away 5. So therefore, how many left over? There's a 3 left over. And then here means a takeaway. All right. The next one called a missing added model. Missing added model. What is a missing added model? Alice has read 5 chapters of her book. If there are 8 chapters in total, how many more chapters does she need to read to finish the book? So this one we need to using subtraction to finding out the answer, right? So therefore, we can say 5 chapter already, read, and then add the missing added, and then the total is 8, right? So therefore, this is kind of early stage when we teaching like middle school for solving for x. It's something like this, right? Solving for x. So therefore, we take a 8 minus 5, and then we got the unknown number. So missing added, okay? The next model is called the comparison model. So we compare two quantity here. For instance, Georgia has 8 mice and Tanya has 5 mice. How many more mice does Georgia have than Tanya? So therefore, we take compare 8 and 5. So therefore, equal 3. And then number line model. Mike hiked up the mountain trail 8 miles. 5 of these miles were hiked after lunch. How many miles did Mike go before lunch? So I think I would draw a number line like this. And then here we say lunch. And then this say after, okay? After lunch, 5 miles after lunch, because we already know the information after. So which is 5 miles. Now before, right here, we don't know, right? But the total is how many? Is 8. So we take a minus 5. We can do finding out what's the known number, right? So sometimes using the number line, sometimes using the picture will helping us to helping children to solve the problem, okay? Now again, here is several different methods I want to talk about. Subtraction method, just like we did the addition method, we use in different way, to talk about methods, okay? And we have draw pictures, we have tally marks, we have come back on number line, we have decompose, compose, and we have a CAP method, we have a New Zealand method. Again, we are always from easy to difficult. Okay, so I want to introduce from easy to difficult, from slow learner to quick learner. Okay, from slow learner to quick learner. Then we will cover all the diverse students in the classroom. Okay, now draw pictures. Let's say we have a minus 2. And I will say, oh, I have 8 apples. 1, 2, 3, 4, 5, 6, 7, 8 apples. Okay. And subtract, that means take away here. I want to take away 2. How many left over? Which is 6. So this is a takeaway. Okay, so people do not have any question with the pictures, right? But this is all good for slow learner, okay? Another one, this is a concrete way. This is a concrete way. Another one, we use a tally marks. Okay, tally marks. So again, a minus 2 equal how many? So we add 1, 2, 3, 4, 5, 6, 7, 8. Then we want to take away 2. How many left over? So we put 1, 2, 3, 4, 5, and 6. Tally marks. Next one, come back on number line. Remember when we do addition, 8 plus 2, right? That means we start from 8. Addition, that means forward. 2 moving another 2 units, positive unit, right? Now here, subtract. Again, we have a minus 2. And we're going to give a meaning for each. This means start. This means forward or backward.
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 Backward this time because subtract. Thank you. Just checking you are pay attention. Right? Okay. Now 2 unit. Okay. So I wanna do a number line here. Two, 3, 4, 5, 6, 7, Okay, starting A minus 2 is starting. So everything starts from here. We have A. That means A. Are you with me? Starting
Yes.
from A. Then we want to backward, minus backward. So backward. So want to backward for how many unit? We want to backward for 2 unit. Backward for 2 unit. So backward for 2 unit, that's 1, that's 2. So the car is right here, 6. So here is a backward. Subtraction means a backward. Okay. Next one, decompose and compose method. So 8 minus 6. We can decompose 8. If we decompose 8 with a 4 and 4, is gonna help us, yes or no?
Yes.
If we decompose this, it's gonna help us with the calculation. We can decompose this, but it's not gonna help us with the calculation. What is the best way to decompose? Remember, when we review last week, I have $8 in my pocket, and I want to buy Starbucks coffee for $6, right? Remember that?
Yes.
Telling the story. So therefore, I think I would decompose 6 and 2 because the 6 I have enough. Is that right to pay this? Are you with me for this? You can
Yeah.
decompose 8 and 7 and 1. You can decompose 4 and 4. You can decompose 6 and 2. And which one is better? I think the 6 and 2 is better because that shows enough money to pay for the coffee. Is that right? So I have $8 in my pocket. I wanna pay for $6 for coffee. How much money I left over? So I have 6 plus 2 minus 6. And this one I have enough. And then what I have left over, I have 2. Does that make sense to you for decompose?
Yes.
Yes.
How about, see, this is all related to the last time we called about for the pretest, okay? How about this one? 23 minus 15. Look, student always have problem with not enough. And how can we help them with not enough? We can do the regrouping, we can do the decompose. I think that the effective way is to do the decompose. That helps them to see the picture. So 23, I want to decompose 23 as one number and one number together.
15 and 8.
Very good. So 15 and 8. 15 and 8. So this one, look, I have enough, right? So therefore, 15 plus 8 minus 15. Oh, I have enough to pay for let's say, a bag of cherry. A bag of cherry is $15. I have $23 in my pocket. How many I have left? I have $8. Does that make sense?
Yes.
Yes.
Right? And this one we can taking care of the not enough, right? Not enough. Okay. Sometimes students struggle with not enough. I cannot subtract. How should we do? Do we have a better way to do it? Yes, we do have a better way to do it. One of the better way to do it is using the decompose, right? And let's see. Can we do another practice with decompose? Okay, go ahead and do this problem. 24 minus 17, not enough. 4 minus 7, not enough. How should we do this? Can we do decompose method? I want you to give you a minute and try it, okay? All right. Now 24, we can decompose. 24 is 17 and 7. Is that right?
Yes.
And we still leave 17 there. 17 minus 17, 0. 0 minus 0, so 7. We still have 7 left over. And I have enough money to pay for 17. And I still have $7 in my pocket. And you can make a story for students because sometimes we not just do the algorithm here. We sometimes, if we can make a story connect to the real world context, and that would make sense to them. Okay. Does that make sense to you in terms of teaching?
Yes.
Yes.
Next method. Sometimes when I introduce the new method, maybe this is new for you, but I really enjoy the new method because this is a great because I think so. Wow, how come the people can think about this way? You know, this one, another method called a CAP method. CAP method. CAP method. All right, CAP method. So CAP method is another way to taking care of not enough. Okay. For instance, I want to stay with the same problem. Three minus five enough or not enough?
Not enough.
Not enough, right? So we were taking care of the not enough. Not enough for how many? Not enough for how many?
By two.
2.
By 2. Yeah. So not enough for 2. So I want to put on cap 2. Right. And cap 2, that means is not enough. Okay. It's not enough. Right. So 2 minus 1, enough or not enough? 2 minus 1, enough or not enough?
Enough.
Enough.
Yeah.
Enough.
So I take a 2 minus 1. Yes, enough. And what does this mean? This means 10. Oh. The place value here, this means 10. The place value here means not enough 2, right? So 10 plus 2, negative 2, which is 8. Can we do another one for not enough? (24 minus 17). Can you do this one? If not enough, put on a cap. All right. 4 minus 7, enough or not enough?
Not enough.
No.
Not enough for how many?
3.
Three. So I kept 3. Is that right? If it's not enough, you put on a cap. If enough, we just go ahead and subtract, okay? So 2 minus 1, enough or not enough?
Enough.
Enough.
Enough, so therefore put on the 1 there.
Mm-hmm.
So what does the meaning for 1 and cap 3 mean? That means I have a 10 and not enough 3. So therefore I have a 7. Does that make sense to you?
Yes.
Yes.
No.
I think that this way, just don't worry about not enough. Just put on a cap, make things easier. Can you do another problem to practice with this? 28 minus, just a second. 25 minus 18. Okay.
What if it's not a 1? So if it's like 25 minus like 28 or something, would it not be like 10? How would we do that?
If you say 28,
Yeah, because I know
well,
we put 10.
usually, in elementary school, we don't talk about too much the negative number. But actually, we can say not enough, okay? So how about we try this one first, okay?
Okay.
5 minus A, enough or not enough?
Not enough.
Not enough for how many?
3.
3. Okay. Not enough for 3, right? So 2 minus 1, enough. Just put on the 1. Is that right?
Yes.
And that means you have a 10 and cap 3. That means not enough 3. So therefore, we have a 10 with not enough in 3. That means we 10 minus 3 with minus 7. Is that right?
Yes.
Yeah.
Of course, we can do, if a student's okay with this, then we can put on the 22, 28, so no problem, yes. Not enough, 3, is that right? And then this is a 0, is that right? So place value, tens is a 0. And plus not enough 3, so we have not enough 3, negative 3. Does that make sense to you?
Yes.
Yes.
But usually the elementary school, we don't want to answer for negative, okay? We always keep the positive number, whole number. Okay. Can we do another problem for 3-digit number? 321, 184. How about this? I do one problem, you do one, okay? I do one problem, and you do one, okay? 1 minus 4, not enough 3, cap 3, cap 3. If not enough, put a cap right away. If not enough, put a cap 6. Enough, that's 2. Is that right?
Yes.
So this means you have a 200 and you don't have enough 60 and you don't have enough 3, right? So you subtract 60, you got a 140. And you want to subtract 140 from, or take a 140, subtract 3, then answer is 137. Are you with me for this?
Yes.
Can we, okay, now I do this one and you do one, okay? If enough, just subtract. If not enough, just go ahead, put on a cap. And this will make us the subtraction easier when it is coming as not enough. Okay, go ahead. 525 minus 1779. If enough, just subtract. If not enough, put on the cap. All right, all down?
Yes.
All right. 5 minus 9, enough or not enough?
Not enough.
Not enough.
Enough for. Not enough for 5. Enough, so that be 4. So 4, kept 5, and kept 4. What does this mean? That means I have 400 and not enough 50 because this is a tens, is that right?
Mm-hmm.
And not enough 4, is that right?
Yes.
So I take a 400, subtract the 50, got a 350.
Mm-hmm. Plus.
And then I take a 350 minus 4 or 346. So children will not worry about any not enough. They are always happy with this because they will get the answer correctly. All right, so this is a CAP method. I wish you like it. And then I like it. I'm not sure you like it or not, but this is a alternative way to helping children, to know not enough, how we taking care of not enough, okay? Next one, and maybe this is the last method for today, okay? The last one for today. I'm gonna take you to New Zealand, okay? This is called the New Zealand method. And this is the method in New Zealand people are using this way, okay? I'll take you to New Zealand. I wish someday I can visit New Zealand because there's so many cow, sheep, right? Beauty nature. Okay, so give you a background information for New Zealand method. Let's say 9 minus 3 equal 9 minus 3 equal how many?
6.
6, right? 9 minus 3 equals 6. Now the New Zealand method is they're using a strategy to taking care of not enough, okay? So therefore, if I add 10 on the top, which is a 19. If I add 10 on the bottom, which is 13, and you subtract, what's the answer? What's the answer for this?
6.
Oh, still 6,
6.
right? And what does this tell you? That means if you add 10 on top, you add 10 on the bottom, you still the result still the same. Right? Does it make sense?
Yes.
Yes.
How about another example? 7 minus 4. I add 10 on the top, make it 17. And I add 10 on the bottom and make it as 14. And I do subtraction for this. 7 minus 4 is 3. So therefore, 17 minus 14, which is equal 3. Well, if you add 10 on top, you add 10 on the bottom, the result is the same. Does that make sense to you?
Yes.
Yes. Yes.
Now this is a tens value, okay? How about hundreds? If I add 100 on the top, and I add 100 on the top button, I will make it as like a 107, and make it this is 104, and this is a 3. So the answer 107 minus 104. Hey, we still got a 3. Is that right?
Yes.
Now, if I add 1,000 on the top and 8,000 on the bottom, I make it as 1,007 and 1,004. And this is answer is 3. So therefore, this answer still is 3. Is that right?
Yes.
So New Zealand method basically uses this strategy. Add 10 on the top, add 10 on the bottom. We're taking care of the not enough. Okay. And it depends on the place value in not enough, okay? Let's say not enough for 10th place value, we go move on to next one, okay? So again, I'm gonna give you the same problem here. Three minus 5, enough or not enough?
Not enough.
Not enough, right? So not enough, so therefore, I add 10 on the top, I add 10 on the bottom. So add 10 on the top, I make it as 13. And add 10 on the bottom, make it this as a 2. Are you with me, my scratch? Because 1 plus, well, 10 plus 10 is 25. Are you with me for this?
Yes.
So 13 minus 5, how many?
8.
So now I have enough. It's not 3 minus 5, it's 13 minus 5, right? That is 8, is that right? Now
Yep.
2 minus 2 is equal how many? 0. Do I have enough? I have enough. So answer is 8, okay? One more time. Maybe sometimes new, so I have to slow down, okay? Make sure you understand what I'm saying. 3 minus 5, not enough. So I add 10 on the top, make it as a 13. Is that right? And then at the same time, and then add the 10, make it as even. If you add a 10 on the top, you don't add a 10 on the bottom, not even, so it's not working. You have to add 10 on the bottom. So I scratch this one and make it as a 2. Are you with me?
Yep. Yes.
So we have a 13 minus 5, which is 8. And 2 minus 2, 0. So answer is 8. We still get an answer like this is 8. Is that right? Like K method, right? Still get it. Right.
Mhm.
Can we do another problem? And this time, I do one problem, you do one, okay? 44 minus 15. Okay, go ahead. Take a minute to it. All right, are we done?
Yes.
4 minus 5, enough or not enough?
Not enough.
So I want to add 10 on the top, make it this is a 14. I need to add 10 on the bottom, and therefore this is a 25. Are you with me?
Yes.
Now, 14 minus 5, how many? Which is 9. Enough, right? 4 minus 2, which is 2. Actually, it's 40. Okay, 40 minus 20, which is 20. So 20 plus 9, which is 29. Did you get it right for this one?
Yes.
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 Okay, very, very good, very good. And we move on to next problem. Okay, I'm gonna give you a little space because that helps for the scratch. I'm not subtract, no, do subtract. 1 plus 1 minus 4, enough or not enough?
Not enough.
So I add 10 on the top. Make it is 11. I have a 10 on the bottom. Make it is a 9. Are you with me for this?
Yes.
So 11 minus 4, how many? We have enough. We have enough right now. It's a 7. Is that right?
Mm-hmm. Yes.
Next place value, 20 minus 90. Because this is a tens value. 20 minus 90, enough or not enough? Not enough, right? 20 minus 90, not enough, right? So I want the next place value, I want to add 100. Make it so 120. Are you with me for this?
Yes.
Then at the same time, I want to add 100 on the bottom. So therefore, 100, I change it into 200. Now I have 120 minus 90. I have enough or not enough? Yes. I take a 120 minus 90, which is 30. Is that right? Are you with me for this? That's why I put on 3. The 3 is actually is 30. Is that right? Take this one. 120 minus 90, we got a 3 this. And 3, which is a 300, minus 200, which is 100. The answer is 137. Does that make sense to you?
Yes.
Yes.
So I think that I want to clean it up everything, okay? This time you do the exact same problem and you do it again, okay? Make sure you know how to do it. Same problem, you do it one more time. If not enough, how we do this? Is it work for you?
Yes.
Okay. Now, this time I like have you to try because you understand the concept for place value, okay? So this time you'll try not to write plus 10 or plus 10. You already know that, okay? This time we will try to do this way, okay? Because you already know the concept here. 1 minus 4, enough or not enough?
Not enough.
Not enough. So I add 10 on the top. I add 10 on the bottom. So I have 11 minus 4, I got 7. Next place value, 20 minus 90, enough or not enough?
Not enough.
Not enough.
Not enough. So I add 100 on the top, and then I add 100 on the bottom. Add 100 on the top, and then 100 on the bottom. So I have 120 minus 90, which I got a 30. Is that right? The next place value, 300 minus 200, that'll be 100. So 137. Does that make sense to you?
Yes.
Yes.
Without writing 10 plus 10, if you want to do this, it's okay. But it's okay. But I think that if you understand, you just put on, once you understand the concept, you can do it very quick. I add 10 on the top and add 10 on the bottom, and then can make a 7. 20 minus 30. And then I not enough, so I add 100 on the top and add 100 on the bottom. So therefore 137. Does that make sense to you?
Yes.
Yes.
How about you try this one? But you can do either way. You can do either way. You want to put a place value there with 100 or 10, doesn't matter. Or if you're okay with this without, anything, like, you can just write the answer right away. If you are okay with this. Okay, go ahead. 532 minus 249. All right, are we done?
Yes.
Okay. 2 minus 9, not enough or not enough?
Not enough.
Not enough.
Not enough. So I add 10 on the top, and I add 10 on the bottom right away. So I put on 4, and then write it down 5. So 12 minus 9, I got a 3. Next place value, 30 minus 50, enough or not enough?
Not enough.
Not enough. So I add 100 on the top, and I add 100 on the bottom right away. Put on the 3 right there. So 130 minus 50, I got an 80. Is that right?
Yes.
And then 500 minus 300, therefore we got 200. The answer is 283. Does that make sense to you for the New Zealand method?
Yes.
Yes.
Very good, very good. Okay, and I hope you can learn this, many methods as you can, and we can taking care of diverse learner from slow learner to quick learner. And I would say probably New Zealand method and CAT method would be good, for more quicker learner. Okay, but anyway, now the more method you learn, the better. Okay, as a teacher. Okay.
Mhm.
So we are here for today. And then if you have any questions you want to ask me, and you can stay here, okay? Otherwise, we are here for today. Thank you.
Thank you.
Thank you. Thank you.
See you next week. Don't forget tomorrow
Hi.
we have a post test, okay?
And we can pull this slideshow up on the Blackboard.
Oh, which one you want us? Okay, let me.
The one you just did, we can pull that slideshow up. Is it on there?
Yeah, I think the slide after finish every time I finish, I will upload the slide to D2L.
Thank you.
All the
Is the
information, and then also the recording. I did a recording. You can go back if you don't understand. You can go back for the video, and every time finish the class, I will send you the video.
Can you tell me if you can hear me?
Yeah, I can hear you.
Yes. Okay.
Yes.
Got my microphone working.
is the pretest due tomorrow?
Pre-test, no. The problem said is due today, and then post-test is tomorrow.
Oh, okay. Thank you.
Post-test, you find that your convenience time to do it. So
Okay.
let's say you are available for 9 o'clock, and you can do it 9 o'clock. Let's say you're available for 2 o'clock, and you can do a 2 o'clock. Okay. So
Okay.
tomorrow whole day you can find the time. You can do it just like you do the problem say number 1. Okay.
Gotcha. Okay. Thank you. Have a good day.
Thank you. Bye bye.
Okay,
Bye-bye.
so where would the post test be posted?
The post test will be posted. I mean, tomorrow morning I will post it tomorrow morning.
Okay. Okay, got it. Thank you. I was just trying to make
Tomorrow
sure I wasn't
morning.
like overlooking it.
Yeah. I
Okay,
think
have
so.
a great
I
day.
set up the timeline tomorrow. When during the morning, you should be able to see it.
Okay. Sounds good.
All
Have a
right.
good day.
Bye. Bye.